Hello, in good evening. My name is Sharina, and today I'll be sharing how modern technologies, particularly AI and also expert systems, can address the growing challenges faced by Malaysia's paddy farming sector. Also, the local agriculture sector, especially paddy farming, is facing different challenges, such as climate change, unpredictable weather, and also soil degradation. And despite being time-tested, traditional farming techniques are struggling to cope with these evolving issues. So, artificial intelligence presents an opportunity for farmers in order to support precision agriculture through many ways. Firstly, I can help with yield prediction and also resource optimization. Machine learning algorithms can help to analyze soil data, crop growth stages, and historical yield patterns in order to predict an output and optimize the input usage. The example for this would be UPM-SPART technology framework that integrates different sensors and artificial intelligence in order to estimate plant yield and also guide planting decisions. Next is the labor efficiency through automation. AI-powered drones and robotics can help to automate different tasks like seeding, spraying, and monitoring in order to help with labor shortages while also improving the consistency of the job done. Malaysia's Digital Agitech initiative is an example for this, and it has shown productivity gains through such technology. Next is the climate adaptive decision support. AI-powered weather forecasting tools can help farmers to plan for different methods and schedules based on local climate predictions. An example of this would be Paddy Watch that was developed by University of Malaysia Terengganu that monitors crop health and predicts the weather impacts on the crop. And lastly is the smart pest and disease management, in which AI models are trained on image datasets in order to detect early signs of pest infestations and also recommended target solutions. This can help with to reduce pesticide overuse and also protects both the yield and also the environment. Next, we will dive into the role of expert systems in agriculture decision making. So it can help to provide contextual advice by using the soil type, weather, and also crop stage in order to suggest best practices for fertilization, irrigation, and also pest control. And next can also help with enabling real-time monitoring by integrating IoT devices in order to alert farmers to anomalies and recommend corrective actions. An example of this would be the paddy expert system developed by a university in India. So my proposed expert system would be WIE, a smart paddy expert system that is AI-driven and designed to support Malaysian paddy farmers with timely, localized, and data-backed farming advice. These are some features in the WIE expert system, which is disease and pest diagnosis, decision support system, climate-responsive guidance, and also geo-localized crop advisory. So for the life cycle of the proposed expert system, firstly, we need to identify the problem domain in which we need to find the suitability, which is for the Malaysian paddy farmers that face problems such as climate-induced risks, inconsistent irrigations, and other different challenges. The domain experts will be the agronomists, experienced paddy farmers, and also agriculture extension officers. And lastly, you can find the the cost effectiveness, which is by improving yield and reducing crop loss, which offers a strong ROI. Next is we need to design the system, in which we need to identify the ES technology, which is will be system with IoT integration. And the system integrations, you can integrate the ES with, for the system integration, you can integrate the ES with local radio databases and also agriculture IoT devices. And lastly, we need to find the knowledge representation. Next, we need to develop the prototype, in which we need to do some knowledge acquisition by interviewing farmers across states and also doing some field observation. And then we also need to do some rule encoding by translating the expert knowledge into a certain logic. Next, we need to test and refine the prototype, which is by doing technical testing and user testing. For technical testing, we can use actual field data to evaluate the predictions, and also for user testing, farmers can interact with the app on live demo plots. Next, we need to develop and complete the expert system, in which we need to ensure there are seamless integrations with different IoT sensors and also existing databases. We need to do some proper documentation and also train the users or the farmers that is going to be using WIE. And lastly, you need to maintain the system by you giving them regular updates and also ensure compatibility with different devices. So in my opinion, the most critical phase in the life cycle would be developing and completing the ES, in which it is the most important stage where the knowledge becomes intelligence and where the general theory gets changed into situational intelligence. The errors and gaps discovered in this phase will tell us what additional knowledge we need to be captured in order to make the system fully reliable. And early farmer testers are more likely to vouch for the system to the other farmers if it proves that it is helpful from the start. So that is all from me. Thank you.